Welcome to Get Your FRQ On. This question is from 2017. It is question 3 and it is not calculator active. In the question stem, we have a function f which is differentiable and defined on the closed interval from -6 to 5. We're also given that f of -2 is equal to 7. And we have the graph of the derivative of f, which is 3 line segments and a semicircle, and there's also a couple of ordered pairs on that graph for reference. In part A of the question, we are asked to find the values of f of -6 and f of 5. F of -6 can be found by taking f of -2 and adding it to the integral from -2 to -6 of f prime of x dx, which is f of -2 minus the integral from -6 to -2 of f prime of x dx. Use the graph to calculate the area, and f of 5 is f of -2 plus the integral from -2 to 5 of f prime of x dx. So if we use the graph of f prime of x, f of -6 is f of -2 minus the integral from -6 to -2 of f prime of x dx, which is going to be 7 minus 4, which is 3. And f of 5 will be f of -2 plus the integral from -2 to 5 of f prime of x dx, which is going to be 7 minus 2 pi plus 3, or 10 minus 2 pi. In part B of the question, we are asked to determine the intervals where f is increasing and to justify our answer. We know that f of x will be increasing whenever f prime of x is positive, so we will use the graph to determine those intervals. Based on the graph of f prime of x that we're given, f prime of x is greater than 0 on the interval from -6 to -2, inclusive at -6, exclusive at -2, and then again from 2 to 5, exclusive at 2, inclusive at 5. We can also tell from the graph that the definition of increasing would still be satisfied at both -2 and +2. So we can actually update our solution here and state that f of x is increasing on the closed interval from -6 to -2 and the closed interval from 2 to 5. In part C of the question, we are asked to find the absolute minimum value of f on the closed interval from -6 to 5 and to provide justification for our answer. The absolute minimum value of the function f of x on the closed interval from -6 to 5 will occur at an endpoint or somewhere on the open interval from -6 to 5 where f prime of x is equal to 0 and changes from negative to positive. Those are the only places this can happen. Given these criteria, the only such candidates are -6, 2, and 5. We've already determined that f of -6 is 3 and that f of 5 is 10 minus 2 pi, which is greater than 1. And f of 2 we can find, that's 7 plus the integral from -2 to 2 of f prime of x dx, which is 7 minus 2 pi, which is less than 1. Given this information, we conclude that the absolute minimum value of f of x on the closed interval from -6 to 5 is 7 minus 2 pi. In part D of this question, we are asked to find f double prime at -5 and f double prime at 3, or explain why they do not exist. F double prime at -5 we can find by using 2 minus 0 over -6 minus -2, which is 2 over negative 4, or just negative 1/2. For f double prime at 3, we're going to look at two limits. The limit as x approaches 3 from the left of f prime of x minus f prime of 3 over x minus 3 is equal to 2. And the limit as x approaches 3 from the right of f prime of x minus f prime of 3 over x minus 3 is negative 1. And the important thing about that result is that the left-hand limit does not equal the right-hand limit. So the conclusion to draw here is that f double prime at 3 does not exist. If you want more AP Calculus AB free response question solutions, don't forget to like my videos and subscribe to my channel. You can also follow me on X at x.com/getyourfrqon.